All right, so let's see. So we just did 221, 2-tac 56. So now we're on 222, 2-tac 61. And this is a drawing graph paper problem, so we're going to skip that one. We should probably buy some graph paper pretty soon, just so we can get used to graphing. And then what do we got here? The ratios Casey wrote from part A of problem 258 are ratios of the lengths of corresponding sides of the two shapes. Look at the similar triangles below. Which sides correspond? Write ratios for the corresponding side lengths. Calculate the length of the hypotenuse of each triangle. Is the ratio of the hypotenuses equal? Oh, okay. Yeah, so this is kind of cool. So if these two triangles are similar, right, so they're not congruent because the sides are not exactly equal, but they could be similar triangles, right, because the angles are all equal, which means that this triangle, if you just kind of expand it equally, it will become this triangle at some point, right? And so this triangle, one could imagine that this triangle might be like maybe half the size of this one. We know it's not because 8 is not half of 20, it's actually less than half, but there's a constant ratio between the sides. So they want us to find out what the ratio of the sides is, and then that can help us get the actual calculation for this hypotenuse, or one of the hypotenuses. So let's just go ahead and do that. So here we go. All right, new equation. So it says calculate the length. Oh, well, it says first which sides correspond. Write ratios for the corresponding side lengths. Okay, well, 15 corresponds to 6. So we can say the ratio is 15 to 6. I'm not sure if you're familiar with that form of writing ratios, 15 to 6. So if you ever see the ratio like 2 to 1, right, or 1 to 2, or 3 to 1 odds, or maybe 10 to 1 odds. So that's one way of writing ratios. You can also write it as a fraction, so you could write 15, 6, or if we write it as an actual old school, 15 to 6. So that's one ratio right there. And then we can write another ratio over here too. So we could say that the other ratio is 20 to 8. Right? So one ratio is 15 to 6, another ratio is 20 to 8. And then we can just compare because they want us to just see like what is the ratio. Write the ratios, so let's go ahead and just calculate that out. So what is 15 divided by 6? 15 divided by 6 equals 2.5. Alright, so equals 2.5. And so what does 20 to 8 equal? So 20 divided by 8 should be the same, 2.5. Cool. 2.5. So the ratio of that side to that side is 2.5. The ratio of that side to that side is 2.5. So when we calculate out the hypotenuse here, the ratio of this hypotenuse to that hypotenuse should be 2.5, right? If the triangles are similar, which so far it sure looks like they are because all the angles are equal, right? Well, actually they are because all the angles are equal. All right. So is the ratio, okay, so now we want to calculate the length of the hypotenuse of each triangle. Okay, so let's go ahead and do that. So let's do the 15 one first. So 15, and then we're gonna, well, let's see, probably easier if I do it this way. So 15 squared plus 20 squared should equal c squared. Let me try that one more time. Equals c squared. There we go. So if this is c, of course. All right, so let's go ahead and solve that one. So this one, that one's pretty easy. That one's 400. 15 squared. Man, I don't remember my 15 squared. What is 15 squared? 15 times 15 equals 225. Ah, I should have known that. 225. There we go. So 225 plus 400 is going to be 625. So that equals 625. So then we got to find out what 625, the square root, is. So 625 square root is 25. Cool. So that's after I square root that one, and then square root that one. So that square root of c squared is c. Square root of 625 turns out is 25. So 25 equals c. So this, the hypotenuse, is 25. Cool. All right, so we got the hypotenuse of the first one, 25. Let's find the hypotenuse of the second one. New equation. Let's go, there we go. All right, so now we've got 6 squared, which we know is 36, plus 8 squared, which we know is 64, equals, I'll call this one d. So this one will be d, and then, well, let's see here. Let me make it a square, so d squared. All right, so what's 36 plus 64? That is 100. Point equals d squared. Well, so if we square rooted this, we get d. If we square root this side, we get 10. So d equals 10. So now the question is the ratio of the hypotenuses equal to the ratios you found in part A? So is 25 divided by 10, is that 2.5? It sure is. And you can double check it. 25 divided by 10 equals 2.5. So yes, so the ratio of this triangle to this triangle is 2.5 times bigger on all sides than this triangle, but they are similar triangles. So describe a sequence of transformations that would map one triangle onto the other. Well, to map this triangle onto this one, you got to rotate it counterclockwise a little bit. Looks like maybe 45 degrees, right? And then you'd have to increase the size by 2.5 times, and then you'd have this triangle. Kind of a neat little experiment, or neat little thought experiment, huh? Let's see what their help says. Use this method to find the hypotenuse of the second triangle. Oh, well. Use the Pythagorean to solve. Okay, well, we used the Pythagorean theorem for both, but I guess they're saying that once we had calculated this hypotenuse, we could have just used the ratio to get the hypotenuse for this one. So how would we have done that? So if we knew that this hypotenuse was 25, and we knew that that was 2.5 times bigger than this one, so we would say that d equals 2.5 times the size of this one, which would we say was 25? Is that right? No, we would say 2.5 d equals 25. There we go. Right, because this thing multiplied by 2.5 equals this one. Okay, so 2.5 times this one equals this one. That's right. So now we have 2.5d equals 25, so we would just divide this side by 2.5, right? Which means we would divide this side by 2.5. That turns this side into d because those two cancel out. And then we have 25 divided by 2.5, which you can see because of the decimal. That's just going to be 25 divided by 2.5 equals 10, right? You can tell because you're just moving the decimal around. So that equals 10. And that's the answer we got using the Pythagorean theorem. Cool. That was pretty straightforward. All right, done with this one.